Good morning, students. In this session, we are going to discuss about types of forces occurs in nature. There are four fundamental forces occurs in nature. They are gravitational force, electromagnetic force, nuclear force, and weak force. Let us discuss one by one. What type of force is a gravitational force? Gravitation force is a long range force. When we take the distance between the earth and the sun, similarly earth and the moon, similarly the planets in our solar system, the distance are millions of million kilometers. They keep on revolving around the sun due to the gravitational force. So from this example, we can say that it is a long range force. And second point, it is attractive in nature. It is always attractive. Whatever object thrown upwards, it comes towards the earth because it is always attractive. And it is central force. The force acting always towards the center, so that it is a central force. And whether it is a strong force or a weak force, even though it is the object, it is at a very large distances, it's keep on attracting the object, so that what type of nature, whether it is attractive, whether it is a strong force or a weak force, it is the weakest force. How can we say that it is the weakest force? From the comparison between the electromagnetic force, nuclear force, and weak force, since these forces are very much stronger than the gravitational force, therefore we say that conclude that the gravitational force is the weakest force. It is the weakest force. Because if we take an electromagnetic force, it is 10 to the power of 36 times greater than the gravitational force. So if we take nuclear force, similarly it is also greater than the electromagnetic force. So we can conclude that the electromagnetic force is the weakest force when we compare with the other three forces. And next point, the gravitational force obeys inverse square law. From the famous Newton's law of gravitation, he studied the gravitational force, and he formulated a formula. From this formula, that is F is proportional to m1 m2 by r squared. From this formula, he stated that the gravitational force obeys inverse square law, because this distance to the power of square, which comes into the denominator. When it comes to the numerator, we can say that it's directly proportional, but it comes to the denominator, so we can say that it is inversely proportional. So gravitational force obeys inverse square law. So these are some of the properties of gravitational force. And we discussed about the electromagnetic force. So why do we discuss about electric and magnetic nature? Whenever there is a change in electric lines or electric flux, then there is a magnetic lines occurs around the wire. Whenever there is a change in the magnetic flux, then there is a induction of electric current. So we cannot separate electric and magnetic nature, so we include both the electric and the magnetic, so that is electromagnetic force. So let us discuss what type of force is electromagnetic force. So electromagnetic force is the attractive as well as repulsive nature. It depends upon what type of charges we prefer, whether it's a like charges or unlike charges. So simply we take an example. Then the magnet, the north pole or south pole repel each other. That is like poles repel each other. Similarly, in charges, that is in electric charges, the positive charge and positive charge, or negative charge and negative charge, both charges are like charges, they repel each other. So the opposite charges, that is unlike charges, are positive, negative, north pole and south pole, that are attractive in nature. So depending upon whether the charge is like or unlike, or poles are like poles or unlike poles, it is attractive as well as repulsive in nature. And it is stronger than gravitational force. It is a long range force. A simple example, you can see that the changes in the sun, changes in the sun atmosphere causes in changes in our Earth atmosphere, also in the solar system. So we know that what is sun? The sun, it is a plasma. It is charges. It is full of charges. It's a magnetic plasma. So the changes in the atmosphere of the sun, which influence the changes in the earth. So we can see that you can similarly see that so many examples. So since the electromagnetic forces is not directly absorbed, we can indirectly observe that the electromagnetic force is a long range force, and it is also obeys the inverse square law from Coulomb's law. From Coulomb's law, F is proportional to Q1 Q2 by R squared. Similarly, just like Newton's law, it is also the distance squared which occurs in the denominator. So we can say that it is inversely proportional to the square of the distance. So that is simply called as it obeys inverse square law. And again, last point, it is one of the important point. The energy of the electromagnetic force is represented by a word that is photon. The photon is a field particle which exchanges between the two charges or two poles. So these are the some of the points about the electromagnetic force. And nuclear force. The nuclear force, it is somewhat peculiar force, because it is just like it is not like gravitational force and electromagnetic force acts for long distance. The nuclear force acts only within the nucleus of the atom, that is within the proton and the neutron. Suppose if we think in vice versa, that is if we think in another manner, suppose the nuclear force is a long range force, then there is no atom, there is no object it can withstand. So nuclear force is a short range force. It acts within the nucleus. It is the 10 to the power of minus 15 meter, 1 femto, 15 feet. It is nearly 10 to the power of 5 times smaller than the atom. But it keeps on, it's a proton. Since it has a positive charge, repulsive in nature, even though it is a repulsive in nature, it is confined to a very small size, that is 10 to the power of minus 15 meter, that is radius of the nucleus. But it overcomes the repulsive force and keeps on in the nucleus and also the neutron. So from that we can say that it is nuclear force, it is a short range force, also it is a charge independent, and it is the very strongest force. It is strongest force means it overcomes the repulsive forces between the two protons, the two positive charges. So it is stronger than the electromagnetic force. So compared with the other three forces, gravitational, electromagnetic and weak force, it is a strongest force. And last one, we can say that it is a weak force. It occurs due to beta decay. It's rarely occurring. It is not occurring in all the atoms. It is all so we are giving most important to the other three forces. Thank you.